Hey everyone, welcome back to the channel. Today we are going to break down into three important matrices used in the regression analysis. First one is the root mean squared error. Second one is the mean squared error. Third, the R squared. So these are crucial for evaluating the performance of your regression models. So let's dive in. All right. So let's start with a quick overview uh, with uh, with our first mean square error. And what it exactly do, it measures the average square between predicted and the actual values. The smaller the value of mean MSE, the better the model fits. Second one, the root mean square error. It's essentially the square root of MSE. So it's the same unit as the targeted variable, so it's easier to interpret it. Third one, the R square. So this gives the proportion of variance in the dependent variable, which is y, that is predictable from the independent variable, mostly the x and the number of features. So the higher value of r squared value, it indicates a better fit. So it is between 0 and 1. The 1 represents the better, uh, almost 1 represents the better fit from the model. So let's go ahead and explore each of these with some code example. So first, let's import some libraries and generate some data. If I just run this, and let's generate some data, for example. So we are going to use the Python NumPy, pandas, and scikit-learn, sklearn for this demonstration. So to generate the random data, I'm using the NumPy random rand, and it is creating the features and the x and y values. Next, I'm using the trains test split function to split x and y into to train and test sets with 20% of our test size. Now, so we have a simple linear regression between y is based on the x with some added noise. We'll split our data, which is we have already done. So let's just call our linear regression model, and it's time to make some prediction. So here I'm using the test values and storing those into y prediction variable. Now, moving to the next part, let's start by calculating the mean squared error. So we can calculate the MSE using the mean squared error function from the scikit-learn. So if I just run this, and our mean squared error is 2.6, which is good. So the mean squared means is a cost function, and the minimum value of mean squared error is good. Now let's and also just the mean square error function give us the average of the square between the actual. So our actual values were y test, and the predictive values were y PRED prediction. Thus, as I said, the smaller MSE value means the better fit. So now let's calculate the root mean square, which is nothing but just the square root of the mean square. So here I'm using NumPy square root function to calculate the root mean square error. So root mean square error give us an error value in the same unit as the target variable. And as I said, it is easier for us to interpret the values. And root mean square is useful when we want to understand how much error we are dealing with in context of the original data. For instance, if our target variable is in dollar, the root mean square error will also be dollar, which is often more interpretable. Now let's move to the R squared, which tell us how well our regression model fits the data. Specifically, it measures the proportion of variance in the dependent variable, which is y, that is explained by the model. So here R squared is pretty high. It's 0.96, almost perfect. This is the generated on the random data. So we are not focusing on the values, but we are just want to know what is R square. So here I'm using the R2 square function from scikit-learn, which calculate the R squared value. And R squared value close to 1 means the model explain most of the variance in the target variable, while if the value is close to 0, it indicates a poor fit. So it is also helpful to visualize the performance of our model. So let's plot the true value versus the predicted value. So if I just import the matplotlib library and run this code, which is nothing, I'm just plotting the true values versus the predicted values. So this scatter plot show how close are predicted values to the actual values, and the closer the points are to the red, the better the model prediction, right? So to recap, MSE mean square error tell us about how off our prediction are on average, but in the square unit. Root mean square bring it back to the original scales of the target variable, make it easier to interpret it. And R square tell us about the proportions of variance explained by our model. Higher R square value is the better. So these matrices give us a good sense of how well our model is performing, but it's important to remember that each matrix has its strength and the weakness depending on the context of the problem. So that's all for this video. Hopefully this help you to understand how to calculate, interpret the mean squared error, root mean squared error, and the R squared. If you enjoyed this video, make sure you give it a thumbs up. Subscribe. Thank you.